Olympus Mons, 3 times the height of Everest. Olympus Mons, 50 times the volume of Mauna Loa, Earth's biggest volcano. Olympus Mons, greatest volcano in the solar system. These cliffs alone tower 6 kilometers. From the surrounding terrain, Olympus Mons rises 25 kilometers. The base is as wide as the state of Colorado. This is the Red Planet, and despite a chain of enormous volcanoes to the east, the supreme feature remains Olympus Mons. Welcome to Mars. And here's the weather. From minus 100 degrees Celsius before dawn, frost and mist disperse in the morning. The sky is pink with Martian dust. Winds are light and variable. At midday it's fine and clear, with an afternoon high just above freezing. But as sunset approaches, ice clouds appear and temperatures plummet. Mars lies 228 million kilometers from the Sun, the 4th planet out. One orbit takes 687 days. A Martian year is almost twice as long as a year on Earth. With a diameter of less than 6,800 kilometers, Mars is little over half the size of Earth and 1/9 its mass. Both have similar axial tilts and rotation speeds. To us, the Martian day is a comfortable 24.5 hours. Mars is the world on which next we'll walk, and we're getting familiar. The north, smoothed by the flow of lava plains, has the younger surface. The south is more rugged, heavily cratered from old impacts. Roughly marking this divide is the Great Rift of Mariner Valley. It would stretch coast to coast across the United States, the largest geological fault in the solar system. Approaching again from the south, we turn west for a sweep down the valley. At a maximum 7 kilometers deep and 600 wide, this is the grandest Grand Canyon. West of Mariner, we climb towards the Tharsis Ridge and 3 volcanoes. First, Arsia Mons, then Pavonis Mons, and finally Ascrius Mons, summits rising over 20 kilometers. This craft, Mars Global Surveyor, has revolutionized our view of the Red Planet. By bouncing pulses of laser light from the surface, it's mapped the contours of Mars. Here in false color, red and white indicate highlands. Lowlands are in green and blue. The deepest blue represents the deepest depressions. The very deepest is the imprint of a huge impact. Hellas, whose basin floor is 5 kilometers deep. And picked out in white, Olympus Mons and the triple volcanoes of Tharsis. Today it's too cold for water to flow on Mars, but it probably did when these peaks erupted. Rising from the depths, hot magma may have melted subsurface ice, unleashing vast quantities of water, flooding the terrain. Beneath ash and lava to the east of Tharsis, Global Surveyor has imaged an ancient flash flood channel, here in blue. Mars abounds with evidence of floods. Etchings of catastrophic outflows. Dug into the surrounding plain, this channel is 3 kilometers wide. Compared with the arid planet of today, early Mars may have been warmer and wetter. A great sea, called Oceanus Borealis, could have filled much of the northern hemisphere. The reason may have been global upheaval, volcanic gases thickening the tenuous atmosphere, sending temperatures soaring. It may even have rained. As eruptions melted subsurface ice, Mars could have flowed with water. Are these layered rocks the relics of lakebed or seafloor? If so, why did the water disappear? Probably volcanic shutdown. Eruptions no longer replenished the atmosphere. It leaked into space due to weak gravity. The seas ran dry. Residual water froze beneath the surface. These tiny volcanic cones, less than a kilometre across, are further clues of a watery past. We see similar features on Earth, where geothermal springs vent through swampy water. Mars today is a freezing waste. The only visible water, polar ice. At its smallest in summer, this is the southern ice cap. It expands in winter. The northern cap is slightly darker because, when it grows, there's more dust in the atmosphere. 5 kilometers deep, scientists forecast that if both ice caps melted, the entire planet would flood to a depth of 10 meters. The elliptical orbit of Mars has quite an effect on its seasons. In the north, when the sun is closest, winter is short and mild. Summer, when the sun is farthest, is long and cool. The north has moderate seasons. In the south, they're more extreme. When the sun is more distant, southern winters are long and bitterly cold. Southern summers are short and relatively warm when the sun is closest. Most of Mars is a dusty desert, red due to the iron oxide. These are trails of dust devils, whirlwinds whipped from particles, finer even than talcum powder. Major dust storms can last weeks and blanket the planet. Since life depends on it, evidence of water remains the great quest on Mars. Here, grooves run down the slopes of a great valley. They're recent clues, possibly of short-lived cascades, released from an exposed layer of rock just beneath the cliff top. With water the objective, an American probe, Mars Odyssey, slots into Martian orbit. The mission is to scan the planet for signs of water ice just beneath the surface. Penetrated by cosmic rays from space, the surface throws out gamma rays and neutrons. They reveal subsurface elements. If there's hydrogen, it signals water, water locked up as ice. Sensing hydrogen, and revealed in dark blue, Mars Odyssey has detected vast reservoirs of underground ice, especially round the poles. In 2003, a new phase of Martian exploration. The European craft Mars Express deployed the lander Beagle 2, but as descent began, contact was lost. Undeterred, Mars Express surveyed the planet from orbit in high-resolution stereo. A plateau rising 3,000 meters. A crater 55 kilometers wide. Top shot of a volcanic summit. Hard on the heels of Mars Express, the Americans successfully landed Spirit, the first of 2 rovers. It may look unremarkable, but this is the real surface of Mars. Did water once flow here? And if so, was there life? After 68 days, Spirit reached this crater. It's 200 meters wide, rocky, sandy and windblown. 3 weeks after Spirit, on the other side of Mars, the lander Opportunity rolled into this crater. It was a bullseye. At this site, Opportunity confirmed there had once been water. And at this crater, Opportunity found exposed dark rock that may have clues to the distant past. The rovers did well, but a new sort of lander is needed. It must be intelligent and highly mobile. It must return Martian samples to Earth. Eventually, of course, humans will do the collecting, on this planet of the god of war.